Let's continue working on data trees here. Once again, I'm going to bring down vector, grid, hexagonal because I know that it gives me a data tree that I can work with. We've already seen how to visualize this a little bit. I'm going to do two things. I'm going to first visualize here the center points of each of my hexagon cells. Then I'm going to go to display vector point list. Let's make those numbers a little bit bigger. I'm going to right click on S, set number to 1. So now we see those values pretty clearly and we see how our data tree is organized. We have rows of hexagon cells. In each branch, I have 5 and then 5 branches. Let's look at the structure a little bit by going to params, utilities, param viewer. Here we have data with 5 branches and I have 5 elements in each branch. We have the path names over here. To make this a little bit easier to work with, let's go ahead and simplify those paths names because right now we don't need the extra zeros here. I'm going to right click on P, say simplify. With this kind of path and indexing, we can really retrieve any item we want on this list. We saw before how we can use tree branch to specify different branches of the tree. We can even go further and go to sets, tree, tree item to really get into the exact item we want to grab. So if we plug in a tree here, it's going to ask us first for the path. I've simplified the path to make this a little bit easier. Let's just use a slider. Let's double click here and go from 0 to 4, and that's going to be our path. I'm going to plug that into P. And in I, it's the item index. So first we're selecting a path, and then we're going to select the item on the path. Let me copy that one. Since we have 5 and 5, I haven't modified the initial hexagon component, so this will be just fine. Now you see that it's at 0, 0, and I have my point right here at 0, 0. So if I start moving this, you see that now I'm traversing the item on path 0. If I move over to path 1, now I have path 1, item index 3. By shifting the path, I can go across the data tree, and by shifting the index, I can go up and down. It's a really powerful way to be able to just grab anything from this nested data structure. What else can we do here? Let me turn the preview off of the tree item component. Let's keep this idea going. Let's say that I wanted to create some lines between the cells. If I went now to curve, spline, polyline, and connected the points, I'm going to get lines that go from the first point in each branch to the last one. Based on how my cells are grouped, I'm going to connect all the center points of each of my different branches. Turn off here the grid a little bit better. Why does this work like this? Well, the polyline component only sees one list at a time. What it's actually seeing, it says, hey, I have 5 points here, so I'm going to make a line. Wait, I'm not finished. I have another list of points. Let's make that line, etc., until it finishes with all of the branches in the data tree. And that's going to be the same for any component. It's going to take a look at one list of data at a time and eventually just continue working until it's finished all of the branches in the tree. What else can we do? Imagine we wanted to connect from the first point here to the first point in the second branch. The first point in the first branch and the first point in the second branch. Essentially, I want to make a connection that shifts the branches just one unit. Over in sets, where we have the tree components, sets tree, we have a component called relative item. And we can use simple masks or simple combinations of elements to retrieve specific items of the tree. Here's what I mean. I'm going to use this simple idea that I just want to connect from one branch to the next one. That means that anywhere I am, for example, 3, I want to connect to the same item, but just on the next branch. So that's just going +1 in the paths. Let's connect my tree here. The offset is the relative offset. What I'm going to get back are 2 sets of data. Let's see how that works. Let's double click here, and I'm going to make a panel with quotations. I'm going to open up a curly bracket, put in a 1, and I'm going to close the curly bracket. What this is saying to the component is that I'd like you from the original tree to give me back 2 sets that shift just one path. I'm going to get a set, for example, with this point, probably that's going to come out of A, and I'll get a set with this point that's going to come out of B because it's shifted one path. Let's connect that. We plug it in, it seems all right, and I'm just going to make that bold for you. I'm going to go to here, font settings, and sans serif, so you can see that this is a curly bracket, meaning that we're talking about paths. we're going to shift in the path, so we're going to get a relative item combination set, which represents this shift. What that means is that now, out of A, I have the first index and the first point that I'm talking about, and out of B, I have the next one. To visualize this, let's go to curve, primitive, line. I'm going to connect from A to A and from B to B. And look at that. What's happening now is I'm starting here at 0, and I want a relative item to this, but just shifted one path. So we get this one. From this point, I want a relative item that is shifted one path. We get this one. Let me turn off a few things here. I'm going to turn off the polylines that are connecting the center points. I'm going to make this a little bit easier to see, so I'm going to go to Surface, Freeform. Let's extrude these lines just so we can see them better. I'm going to connect the lines to B, and I need a direction for extrusion. Let's make that Z. Let's go to Vector, Vector, Unit Z. We can see this a little bit better. So the relative item component is giving me a match based on this pattern that I set. Anywhere I am, I'm going to get back an item that is relative to me by one path. If I'm here at branch 1, index 2, if I shift a path, I'm going to be on branch 2 and eventually the same index. We could change the index, but we have to write it in a slightly different manner. In curly brackets, we talk about the path. So now if I said, for example, 2, we're shifting now 2 paths. From here, I want a relative item that is 2 paths over. We skip this one and we go to the next one. 1 and 2, 1 and 2. You'll see that in some cases, obviously, we're not going to end up having any matches, and that's what the WP and WI are for. Essentially, it's removing any wrapped elements. If we say 3, we're going to get a relative item that goes 1, 2, and 3 paths. And eventually 4, we start here, and we get a relative item that's 1, 2, 3, and 4 paths over. Let's go back to just having a shift in one path. We start here, and we shift one path. Let's say that we wanted to also shift in the list itself. What we're going to do is we're going to open up our panel, and now we're going to write in parentheses the number of items we want to shift in each list. Now I'm going to shift one path and one item on the list. Let's say OK. Shifting a path and one item on the list. Shifting a path and one item on the list. Path, one item on the list. We can start to get some pretty interesting ways of traversing data trees using some of the tools that are in sets, tree. We've looked at now just relative item, but there's a lot of other tools here that we're going to be looking at very soon to continue our data tree work.